Hello, Algebra 1 students. This is the final review for your learning pleasure. All right, so again, this is the answer key for the final review. So the first question here says, list the parent functions that we've learned about this semester. So there are many different parent functions out there. Some of you have found that with your presentations. Some of you have already included those in your answer key. However, not all of the ones that you are listing are part of the ones that we have discussed. So the first one is linear. The second one is quadratic. Some of you are writing it as squared. Quadratic is just fine. We also have cubic. We've discussed absolute value. Exponential. Square root. Cube root, and piecewise. So these are the four graphs that you should know. You should know their equations, and you should know what the graphs on the coordinate plane look like. Question number 2 then is asking about order of operations. So it says, using the order of operations, calculate the value of the expression. The first one we have here is 4 plus 7 times 12 plus 2 minus 5 divided by 9 times 3. So if you remember, our order of operations is parentheses, exponents, multiplication, division, addition, and subtraction. So we're going to focus on our parentheses first. The first one that we're going to do is this one inside, working left to right. I have a bracket here, but then there's one inside here. So I have 4 plus 7, 12 plus 2 is 14, minus 5 is 9. So that's going to be multiplied, divided by 9 times 3. So far I've only done inside that parentheses. Now I'm going to continue with this set of parentheses. This becomes 63 divided by 9 times 3. I'm still continuing to do my multiplication and division left to right. So I have 4 plus 69 divided by 3. 63 divided by 9 is 7 times 3. I'm still doing my multiplication. I have 4 plus 7 times 3 is 21. That equals 25. 25 is my answer. For question B then, I have 7 plus 2 plus 3 plus 2 cubed times 4. So my parentheses is going to happen first. So I have 7 plus 5 plus 2 cubed times 4. Next, I'm going to work with my exponents. So 7 plus 5 plus 2 cubed is 8. 2 times 2 is 4. Times 2 is 8. Times 4. I'm going to continue on. My next step is multiplication. 7 plus 5. 8 times 4 is 32. And now I'm going to continue to add the rest of this. 7 plus 5 is 12, plus 32, or 44. 44 is my final answer. And the last example we have here is 3 plus 4 squared, plus 12, plus 7, plus 3 to the third power. So I'm going to do my parentheses first. 3 plus 4 is 7. 12 plus 7 is 19. Plus 3 cubed. I'm going to continue to work within my parentheses and my brackets. 7 squared is 49. Plus 19. Plus 3 cubed. 49 plus 19 is 68. Plus 3 cubed. 3 cubed is 27. 68 plus 27 is 95. So those are the answers to those 3 problems. Okay. Page 2, now we are working with problem number 3. Our first set of problems tell us to factor the quadratic expression. The equation that we have here is x squared plus 5x plus 6 equals 20. Our problem needs to be in standard form, which is ax squared plus bx plus c equals 0. Our problem currently doesn't equal 0, so we have to make it equal 0. So we're going to subtract 20 from both sides because we want to move this over to the left, and what we do to one side, we have to do to the other. So this gives us a new equation of x squared plus 5x, 6 minus 20 is a negative 14. That is now equal to 0. So now I need to figure out what, let me change colors. I need to figure out what multiplies to my end value that adds to the middle number. So my factors of 14 are 1 and 14, 2 and 7. So I need to figure out which of these values will give me a difference of 7. Since here I'm subtracting, I'm going to have positive times a negative, which is going to give me a negative. So by having a subtraction in there, I'm going to be subtracting one of these two values. 7 minus 2 is 5, so that's the numbers that I'm going to use. I'm going to put my 2 and my 7 in my parentheses, put my variables in front. Now I need to figure out which of these values goes where. I have a positive here, which means that the positive goes with my larger value. And that is my answer. The next problem we have here is x squared plus 3x minus 10. I'm going to do the same steps. I'm going to figure out what multiplies to 10. So I have 1 times 10 or 2 times 5. Again, I have the same thing. I have a negative here, so I'm going to have a positive times a negative, which is going to give me a negative value when I multiply. And actually, let's come back up here to check our answer. You should always be checking your answer. So I have an x minus 2 and an x and a 7. X times x is x squared. X times 7 is 7x. Negative 2 times x is a negative 2x. Negative 2 times the 7 is a negative 14. When I pull those out, I have x squared plus 7x minus 2x minus 14. My middle two terms simplify. So I have x squared, 7 minus 2 is 5x minus 14. That's the answer I started with. So that answer checks. Let's come back to B then. So we've decided that we're using the 2 and the 5. I'm making my parentheses. My first value 2 goes here and 5 goes there. Your variables go in front, leaving space for your symbols. I have a positive 3 here. The positive value goes with my larger value, and the negative goes with my smaller value. Again, we need to check our answer. So I'm going to have an x and a minus 2. Minus 2, the symbol needs to carry along. X and 5, and it does not matter which you put where. X times x is x squared. X times 5 is 5x. And negative 2 times x is negative 2x. Negative 2 times 5 is negative 10. If I pull these out of the boxes, I have x squared plus 5x minus 2x minus 10. My middle terms are what I'm simplifying. X squared, 5 minus 2 is 3. This matches. My answer checks. All right, last problem in the basic quadratic factoring. We have x squared plus 11x plus 24. Again, I'm going to find the factors of 24. I have 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Here I have an 11, so I need to figure out which of these values adds to 11. 1 plus 24 is going to give me 25, so I'm not using that one. 2 plus 12 is 14, not using that one. 3 plus 8 is 11. That's the value I'm going to use. And we can just double check this one. 4 plus 6 is 10, not the values I need. So again, I'm making my 2 sets of parentheses. You're always going to have 2 sets of parentheses because you're going to have 2 factors. My variables go in front, the numbers go in back. I have 2 positives here, so I have 2 positives here. One last time, we're going to check our answer. So I have x and 3, x and 8, x times x is x squared, x times 8 is 8x, 3 times x is 3x, 3 times 8 is 24, x squared plus 8x plus 3x plus 24 is what we get when we pull it out. I'm simplifying those middle 2 terms. So I have x squared plus 11x plus 24. The same answer we started with. That answer checks. All right. So this is one of the questions that I was getting a lot of. We are completing the square. So again, we need to have our standard form of ax squared plus bx plus c equals 0. We have that in all of these problems, so we can go ahead and start. Our first step is to take a b divided by 2 and then put it into the format x plus or minus b divided by 2 squared. So if we want to identify our different values, our a is 1, our b is 12, and our c is 12. We're going to focus on this value of 12. So we're going to take 12 divided by 2 per our formula, which equals 6. So we're going to put that into our format, and we're going to be looking at this symbol. This symbol decides what this symbol is going to be. Since this is a positive, that becomes a positive. I'm going to go ahead and multiply those out. X times 6, x plus 6. X times x is x squared. X times 6 is 6x. 6 times x is 6x. 6 times 6 is 36. I'm going to pull those out of my boxes. So I have x squared plus 6x plus 6x plus 36. Again, I'm simplifying my middle terms. So I have x squared plus 6x plus 36. Now I have to compare this to the original. The only thing that should be different is your c value. Oops, and you can't see that. So I'm comparing these c values. Everything else should be the same. If it's not, you did something wrong. So I have x squared and an x squared, 12x, ooh, and that's my fault. 12x plus 12x. Here I have a plus 12, here I have a plus 36. So I need to figure out how I'm going from the number that I have to the number that I started with. So I have a 36. My number's getting smaller, so I need to subtract some value that gets me to 12. So 36 minus what gives me 12? Well, that's 24. So I'm going to rewrite my format, which is x plus 6 squared, and include this minus 24 to take us from what we had to what we started with. So that is our answer there. We're just going to do that again. For b, we have x squared minus 4x plus 7. You can still identify your a, b, and c. My a is 1, it's that invisible 1. My b is a negative 4, and my c is a 7. I'm going to take my b and divide it by 2. Negative 4 divided by 2 is a negative 2. And I'm going to put it into that same format. So I have x minus 2 squared. We're going to go ahead and multiply those out again. I have an x and a negative 2, x and a negative 2. X times x is x squared. X times a negative 2 is a negative 2x. A negative 2 times x is a negative 2x. Negative 2 times a negative 2 is a positive 4. A negative times a negative gives you a positive. Now I'm going to go ahead and pull these values out again. So I have x squared minus 2x plus 4. I'm simplifying those middle terms. So I have x squared minus 4x plus 4. Now I'm going to compare my equations again. So I have x squared minus 4x. Here I have a plus 7. Here I have a plus 4. So I have a 4, and I need to get to 7. So my numbers are getting bigger, so I'm actually going to add. 4 plus what gives me 7? Well, that's 3. So again, I'm going to rewrite my format, x minus 2 squared, and I'm going to include this value. So I'm adding 3 to get from what I started with, or what I ended up with, to what I started with. All right, and we're going to do that one more time. So I have x squared minus 14x minus 2. So I can identify my a, b, and c again. My a is 1, my b is a negative 14, my c is a negative 2. Per my process, I need to take my b divided by 2. My b is a negative 14 divided by 2. That gives me a negative 7. I'm going to write that into my format and then multiply those values out. X minus 7, x minus 7. X times x is x squared. X times 7, negative 7 is a negative 7x. A negative 7 times x is a negative 7x. Negative 7 times a negative 7 is a positive 49. I'm just going to separate these a little bit. So again, we're going to pull those out of the boxes. So I have x squared minus 7x plus 49. My middle two terms are what I'm simplifying. So I have x squared minus 14x plus 49. So I have a 49, and I'm trying to get to a negative 2. These values are getting smaller. So I need to figure out what hold on, my brain stopped working for a second. So I'm going to be subtracting. So I have 49 and I need to get to negative 2. So 49 to 0 would be subtracting 49. Subtracting another 2 is subtracting 51. I'm going to rewrite my format again. So I have x minus 7 squared minus 51 is my answer. All right. Let's move on to page 5, or problem 5. So here it's telling us that we are factoring using the quadratic formula. So our quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. We're going to identify our a, b, and c again. So a, b, and c. A equals 2. My b equals a negative 8. And my c equals a negative 24. Now that I have these values, I'm going to replace them into my formula and go ahead and calculate that. So the opposite of b, I have a negative 8. The opposite of that is a positive 8, plus or minus the square root of a negative 8 squared minus 4 times a, which is 2, times c, which is a negative 24, all divided by 2 times 2. When we simplify this, we have 8 plus or minus negative 8 squared is 64, minus 4 times 2 is 8. 8 times a negative 24 is a negative 192. And that's divided by 2 times 2 is 4. And I'm going to run out of room. All right, so I have, hold on, let me switch to a smaller pen. So I have 8 plus or minus 64 minus a negative 192 is actually adding. So I have the square root of 256 divided by 4. 8 plus or minus the square root of 256 is 16 divided by 4. Now I'm going to write that twice. So I have 8 plus 16 divided by 4 equals, and 8 minus 16 divided by 4 equals. 8 plus 16 divided by 4, it gives me 6. And 8 minus 16 divided by 4 is a negative 2. So these are your answers. All right, let's move on to B. So again, I'm going to identify my A, B, and C. My A is 4, my B is a negative 5, and my C is 1. So again, I'm going to use the same formula. So my opposite of B is 5, since my B is a negative 5, plus or minus the square root. Let's separate this a little bit. So I have a negative 5 squared minus 4. My A is 4, and my C is 1. All divided by 2 times my A, which is 4. So I'm going to do 5 plus or minus negative 5 squared is 25, minus 4 times 4 is 16, times 1 is still 16. 2 times 4 is 8. So I have 5 plus or minus the square root of 25 minus 16 is 9, divided by 8. 5 plus or minus the square root of 9 is 3, divided by 8. So I'm going to separate those again. So I'm going to do 5 plus 3 divided by 8, and 5 minus 3 divided by 8. 5 plus 3 is 8. 8 divided by 8 is 1. 5 minus 3 is 2. 2 divided by 8 is 2/8 or 1/4. All right, last example then. So I'm going to do the same thing. I'm going to identify my A, B, and C. A is 3, B is negative 5, and C is negative 2. Again, I'm going to take the opposite of my B, which is a negative 5, which creates a 5. Plus or minus negative 5 squared minus 4 times my A of 3 times my C of a negative 2, all divided by 2 times my A of 3. So that gives me 5 plus or minus negative 5 squared is 25. 4 times 3 is 12. 12 times 2 is, 12 times the negative 2 is negative 24. Oh, I forgot to do this one. All divided by 2 times 3 is 6. Okay, so now we're going to do 5 plus or minus 25 plus a negative 24 is 25 plus 24, which gives me 49 divided by 6. So that ends up being 5 plus or minus the square root of 49 is 7. Divided by 6. So I'm going to separate those. 5 plus 7 divided by 6 equals, and 5 minus 7 divided by 6 equals. 5 plus 7 is 12. 12 divided by 6 is 2. Here I have 5 minus 7, which is a negative 2, divided by 6, and that simplifies to a negative 1/3. All right, let's move on to question 6. So it says, using the following quadratic equation, find the following information. So we have x squared minus 12x minus 28. So our first thing we have to do is go back and do this process. So we're going to figure out what multiplies to my end and adds to my middle value. So I have 28 as my number, and I need to figure out the factors. So 1 times 28, 2 times 14, and 4 times 7 are the factors. Here I have a negative. The only way to get a negative when I'm multiplying is a positive times a negative. If I'm adding those when I'm simplifying, it means that I have to subtract at some point. So I'm looking to see which of these values, when I subtract them, will give me a 12. So 28 minus 1 is going to give me 27. That's not an option. 14 minus 2 is 12. That's my value. I'm just going to check the last one. 7 minus 4 is 3. That's not the value I need. So I'm going to put these into my parentheses that are already provided. My variables go in front. The numbers that we're using go in back. And now I need to figure out which of these symbols go where. Nope, that should be a 14. There we go. This is a negative, so this symbol goes with my larger number. My larger number is 14, so that's going to go with my negative, and my positive goes with my 2. I'm going to go ahead and check my answer. So I have an x and a 2, an x and a negative 14. X times x is x squared. X times a negative 14, it is a negative 14x. 2 times x is 2x. 2 times a negative 14 is a negative 28. I'm going to pull these out. So I have x squared minus 14x plus 2x minus 28. I'm going to simplify my middle terms. I have x squared and negative 14 plus 2 is a negative 12x minus 28. That checks. All right, so the next one is asking for the roots. In order to find the roots, we need to have each of these sets of parentheses set equal to 0. So I'm going to have x plus 2 equals 0 and x minus 14 equals 0. I'm going to start with the x plus 2, and I need to figure out what x is by itself. I'm adding 2 here, so I need to subtract. I'm subtracting 2 from both sides to keep my equation the same. So I have x equals a negative 2. Now I'm going to do the same thing here. I'm subtracting here, so I'm going to add 14 to both sides. X equals 14. So these are the roots. This is where the graph goes through the x-axis. So I'm going to have a negative 2 here and a 14 here. The next question is asking, where's my vertex? And there's 2 different ways that we talked about this in class. The first one is if you graph it to find where that middle value is. You can also use the formula. So the formula is the opposite of b divided by 2a. Either one is valid, whichever one you feel more comfortable with. I'm going to use the formula because I find it quicker. So my b is 12, a negative 12. So I'm going to take the opposite of that, which is a positive 12, divided by 2 times my a of 1, and solve. So 12, 2 times 1 is 2. 12 divided by 2 is 6. So my x value is 6. And now I need to put this number into this equation to find the y, because this equals y. So I'm just replacing this into my equation every time I see an x. So I'm going to do 6 squared, because I have x squared, replacing that x with a 6. My symbols stay the same, so I have a minus 12. I have an x again, so I'm going to replace that with a 6, minus 28. 6 squared is 36. 12 times 6 is 72, minus 28. This gives us an answer of a negative 64. So the y for that is a negative 64. So the point where my vertex is going to land is 6, negative 64. Now we're going to find the y-intercept. This one's actually very easy. When we're finding the y-intercept, it's going on this line. That's where the dot that we're looking for or putting onto our graph is going to exist. So we're not moving left or right, so our x value then is 0. So we're going to end up replacing our x value with 0. So I'm going to do this process again, only I'm going to put zeros in for my x's instead of a different value. So I have 0 squared minus 12 times 0 minus 28. 0 squared is 0. 12 times 0 is 0 minus 28. 0 minus 0 is 0. Minus 28 is a negative 28. A quick way to double check your value, whatever this number is where your intercept is going to be. So I have a negative 28. It matches, so that must be correct. Okay, now I'm going to look for my axis of symmetry. That's this value that we calculated down here. My x equals 6. Now it says to graph the quadratic function. So what we're going to do is we're going to be using the values that we just found and putting them on our graph. Since some of our values are very large, I'm going to, let me see which color to use. Let's see if this pink will work. I'm going to adjust my lines a little bit. So this is going to be a negative 10, negative 20, 30. And then I'm going to do these, my x values in 2s. Okay, now I'm going to go ahead and plot the points. So if you remember, our roots were a negative 2 and a 14. So my first point is going to be here at a negative 2. My second point is going to be here at 14. My axis of symmetry is on this line where x equals 6. And that's also where we're going to find our vertex. So our vertex is at 6, negative 64, which is roughly halfway. And if you remember, 3 points determine a line. So we are going to, and then our y-intercept was roughly there at 0, negative 28. I'm going to connect these. And then we need to label the points on the graph. So this is one of our roots at 14, 0. This is another one of our roots at negative 2, 0. This is our axis of symmetry at x equals 6. This is our y-intercept at 0, negative 28. And this is our vertex at 6, negative 64. All of this would need to be on your graph for full credit. The 4 points, the line connecting them, identifying your axis of symmetry, however many roots you have, if you have 1, 2, or none, your y-intercept, and your vertex. So make sure all of that is present if this were on the test. All right, now let's continue on to problem 7. So it says calculate the value of x for the following equations. So we're doing the same thing we did when we were solving for our graph with these problems. So I have 4 times 3x minus 2 minus 6x. And I'm telling you that x equals 4. So I'm replacing these x values with 4 every time I see it. So I have 4 times 3 times x. And instead of writing x, I'm going to write a 4 minus 2 minus 6. I see an x again, and I'm going to replace that with a 4. So I have 4 times 3 times 4 is 12 minus 2 minus, 6 times 4 is 24. So I'm going to continue to solve that. 12 minus 2 is 10 minus 24. 4 times 10 is 40 minus 24. which gives me 16. And I'm going to do that again. So here I have x squared minus 4x plus 3, and I'm telling you x equals 2. So I'm going to have an x, it's going to be squared, 4 times x, my x in this case is 2, so I'm going to replace that x with a 2, plus 3. 2 squared is 4, 4 times 2 is 8, the plus 3 comes along. 4 minus 8 is a negative 4, plus 3 gives me a negative 1. Okay, and the last one. So I have x minus 4 times x plus 2. I have an x, I'm going to replace that with my 7 minus 4. I have an x again, so I'm going to replace that with a 7 plus 2. 7 minus 4 is 3. 7 plus 2 is 9. This gives me 27. Okay, and now we're going to simplify this expression. So I'm going to distribute this into everything that's inside and then simplify using my order of operations. So 7x times x gives me a 7x squared. 7x minus 2 is a negative 14x plus 5x. The only things I can simplify are the 14x and the 5x because they're the only ones that are the same. I do have x's in all three of these. However, this one has an exponent of 2. These do not have a visible exponent. So those are the only two that I can simplify. So I have 7x squared and negative 14x plus a 5x gives me a negative 9x. So that is my answer. Our next two are just multiplying. So you can either use the FOIL method or the box method. I know most of you prefer the box method, so I'm going to go ahead and do that. So I have x and a 4, and x and a negative 8. X times x is x squared. X times negative 8 is a negative 8x. 4 times x is 4x. 4 times a negative 8 is a negative 32. I'm going to go ahead and simplify that. So I have x squared minus 8x plus 4x minus 32. My middle two terms are getting simplified. They're the only ones that are the same. So I have x squared and negative 8 plus 4 is a negative 4x minus 32. All right, and let's do the last example then. So here I have 3x plus 7 times x minus 9. We're going to use the box method again. So I have a 3x and a 7, an x and a negative 9. Make sure you are keeping those symbols with. 3x times x is a 3x squared. 3 times a negative 9 is a negative 27x. 7 times x is 7x. 7 times a negative 9 is a negative 63. I'm going to pull those out and simplify. So I have a 3x squared minus 27x plus 7x minus 63. My middle two terms are what's getting simplified. So I have a 3x squared and negative 27 plus 7 is a negative 20x minus 63. All right. Question number 9, and the last question. It says, graph the following equation, write the equation of the parent function, and graph it on the same coordinate plane. Identify how the graph has changed from the first equation compared to the parent function. So we have a negative 2 times x minus 3 squared minus 4. So we have to do a little bit of work with this one first. So what we need to do is we need to multiply this out so that we get it in standard form of ax squared plus bx plus c so that it's easier to work with. So I have a negative 2 times x minus 3 squared minus 4. This needs to be separated out. So I have a negative 2 times x minus 3 times x minus 3 because this 2 is telling me I have two exact same sets, minus 4. I'm going to, let me see where to do this. I'm going to multiply these two parentheses. So I have an x and a negative 3, x and a negative 3. X times x is x squared. X times a negative 3 is a negative 3x. and negative 3 times x is a negative 3x. Negative 3 times negative 3 is 9. So I have a negative 2 x squared minus 3x plus 9 minus 4. I'm going to simplify this and then distribute that negative 2. So I have a negative 2 x squared, a negative 3 minus a negative 3 is a negative 6x plus 9 minus 4. Now I need to distribute this 2 into everything that's inside so that I can work with this better. Negative 2 times that 1 is a negative 2x squared, and negative 2 times a negative 6 is a positive 12x, and negative 2 times a positive 9 is a negative 18, and then I need to continue with that negative 4. So now I can simplify these last two terms. So I have a negative 2x squared plus 12x, and negative 18 minus 4 is negative 22. Okay. So these are the values that I have calculated for the different x and y values. So you're just choosing different x values, replacing them into this equation, and then you're getting your y values. So I do have all of the work if any of you want to see it. So I have a negative 2 times 1 squared plus 12 times 1 minus 22. Negative 2 times 1 plus 12 times 1 minus 22. All of this simplifies to a negative 8. So when my x is 1, my y is a negative 8. And we already saw before that if I replace these with zeros, I'm just going to end up with this last number. So I didn't do the calculations on that just because I know that these are going to zero out and they're not going to matter anymore. So 0 and negative 22 are my first one. 1 and negative 8 was the second value I did. So again, if you want to check any of these values, I worked all of them out. It's a lot, so I'm not going to finish it. You can check it on your own. All right. So I'm still going to use these values as I calculate this. So again, I'm going to label my graph. It's always important to label your graph because if you just put values down, I don't know if you're counting these at 1, if you're counting them at 4, 7, I don't know. So I'm not going to give you full credit unless you label your graph so that I know, yes, are those points correct, or no, they're just kind of put down there. So I have a negative 1, negative 2, negative 3, 1, 2, 3, 4, 6. Okay. So again, I'm going to be using these values on this graph. Obviously, not all of these values are going to work. Okay, so the first value that we can put on here is negative 6. So I'm going to find 2, come down to negative 6 and put a point. And then I'm going to do 3, negative 4. And you can make these larger so that you can see it better. I felt that this bit of graph was just fine. And then for negative 6. So I'm going to connect those, put my arrows, and that's my original graph. Next, I'm going to see what my parent graph is, my parent function. If you notice, this is in that U shape, so that should automatically trigger you to think, okay, I have a quadratic. Another way you can check is this right here. I have exponents with my variables. The highest one I have is a 2, so that's going to give me that parabola, that U shape. So my parent function is y equals x². It is a quadratic. And if I'm replacing those values, I'm going to do a -1, a 0, and a 1. And -1 squared is 1, 0 squared is 0, 1 squared is 1. And then I believe I did 2's. So I'm going to start by putting these points on my graph. And -2 squared is 4, 2 squared is 4. So that'll really give you an idea of where that shape is supposed to be. So here's my parent function of y equals x squared. And then this is my new one. So I have the -2x squared minus 12x minus 22. So the last thing it's telling me is identify how the graph has changed from the first equation compared to the parent function. So this is where you're going to use those translation rules. So first, here's my parent function. It's opening up. My new one is opening down. So there is a reflection. Now I need to compare the vertex with my parent function versus the vertex of my new function. So my vertex, I'm going 1, 2, 3 units to the right. And then 1, 2, 3, 4 units down. And then we also need to look, okay, this one looks to be opening a little bit tighter than this one. So I'm going to look at my A value, which is a -2. So I have a stretch of 2. So these are the 4 ways, nope, right there, that my graph is changed based on this parent function. I have a reflection because it's flipped. It's shifted to the right, and that's 1, 2, 3 units. And then it's going down 1, 2, 3, 4 units, and it's opening a little bit more tightly, which is why we have the stretch of 2. And that is it. If you have any further questions, please reach out to me either in person or by email, and I'll be happy to help you. Have a great night and good luck on your final.